Okay, good afternoon, everyone. I know I just said there's not a ton of people who've joined us yet. I'm sure other meetings and things people might join a little bit later. But because this is a shorter session, I do want to go ahead and get started. So welcome to the SAS Viya Transition Lunch and Learn. Before we get started today, I do want to go through just a couple of administrative items. So this meeting is being recorded. Please remember to stay muted to minimize interruptions. This session is not going to feature a Q&A session since it is shorter. Please use the Zoom survey to ask any questions at the end of the lunch and learn. And then all meeting materials will be made available in our CCSQ DNA portal after our meeting concludes. Just give us a little bit of time to turn those around and make sure they are 508 compliant. So with that, I'm going to go ahead and stop screen sharing and turn things over to Tim.
Awesome. Thank you so much, Julia. Hi, everyone. My name is Tim. I am a senior data scientist here on the user services team. I've been here for almost 3 months now, and today is actually my second session. My first was yesterday, so thank you for joining my interactive session if you were there yesterday. Today, we are going to do a lunch and learn on data visualization in R. So we have a short session, so let's just get going. Oh, and I will also this notebook should be available to you also, so I can actually send that out right now. Sure, it's the right one. Yes, okay. Okay, so what are we going to talk about? We are going to determine the when and why to use visualization. I know it sounds kind of silly, but it is worth talking about, right? You just want to make a picture. That's when you want one, but it's a little bit more than that. And we're going to understand the different ways to make graphs in R. There are a couple. So I'm going to talk about R's base plot, which is super simple, and it's just super simple. ggplot, which is kind of the most popular data viz library for making static visualizations in R, and also my personal favorite. And then we're going to take a very brief tour of Plotly, because while Plotly is amazing for making interactive graphs, it's not going to work so well with Databricks, which we'll see in a minute, at least in R. So some notes here is when do you make a graph? I know it seems like a redundant question, like you make a graph when you want to show something. But I think that if you can divide these into two separate categories, it kind of really informs your work process. So you can either make an exploratory graph or an explanatory graph. An exploratory visualization is meant to, explore your data. This is what you make just for your eyes only as you're kind of trawling through the data, right? It's done ad hoc, it's unrefined, it sees rapid iteration, it's just for you. Contrast that with an explanatory visualization, which is meant for showing other people, right? This is visually appealing. You're picking the right hex codes for the right colors to be 508 compliant. It's simple. It's publication ready. This is for you to explain your findings to somebody else. So we will, of course, be able to make both these graphs after today, and a quick and dirty one and a publication ready one as well. So visualization in Spark. I know that it seems a little bit silly to say because we're using Spark so much, but actually there really isn't any. So Spark has no built-in viz functionality. Databricks has some, but it's super limited. This means that in order to make a graph, your data need to be collected into the driver node. So all of the data you're using for your visualization needs to be small enough to fit on one computer. This is not so bad because most graphs operate with just aggregated data anyway. So if this is a little bit confusing, I'll show you an example of what I mean by this. But I know it might sound counterintuitive, but in order for you to make a graph, you need all your data in one place. But with data, or with Spark, I should say, all of your data is spread across many places. So it needs to be collected into one place first. What kinds of graphs are there? I'm sure you can name a bajillion different kinds of them, but what kind of graph you make is basically determined by what kinds of variables you want to graph. So I made a quick little reference sheet here. It is, of course, not exhaustive. There's actually a lot more to say about here, but hopefully this kind of makes sense to you. If you have one numeric variable, you're probably making a histogram, maybe a box plot, maybe a density plot. If you have one categorical variable, you're probably making a bar chart. And you'll uh, find it maybe interesting that I included something that doesn't really count as viz here, which is a frequency table and a two-way table, right? Just like a table. I think that there's a inclination for people to always kind of want to make a graph when you don't really need to make a graph. Sometimes it's not so hard to just look at a number. It doesn't need to be like, a multicolored shape, right? Two numeric variables, we're probably going to end up making a scatter plot. And you can go on and on here. There's a million different kinds of graphs, but what I really want to show here is that the kind of graph you make isn't dictated by whimsy. It's dictated by what kind of data you actually have. So our talk is a play in three parts here. So part one is kind of the base visualization in R. So the R programming language does have stuff built right into it. There is depth to it, but it's really a long way to go for a short drink of water in a lot of cases. A lot of the built-in viz is, easy to make easy stuff, but once you get really complicated, it really starts to not feel worth it. So we're not going to spend too much time here. And before we even start running some code here, I do have to run this. So try as I might, the only way to adjust the size of a graph in Databricks is to set global settings. This is not the case if you're using R on your own computer because you can just click and drag the window, but this is really going to control what our graphs look like. So I'm setting here a 700 by 500 viz here, which I think will look good on my screen as I'm presenting it. But if later on, when you've cloned this notebook and want to run this code yourself, if you think that the size of the graph is not appropriate, you can just change this. So we're going to read in some built-in data. If you've ever done like a tutorial in R, you might be familiar with the MT cars data set. We've got cars, miles per gallon, and weight, and those are really the only variables I'm going to use. But there's a lot of other things here. So a scatter plot is as easy as using the plot function. So it's plot of x comma y. So the x-axis is going to be the car's weight. The y-axis is going to be its fuel economy. And if you know anything about cars, this makes sense, right? The heavier a car gets, the worse its fuel economy is going to be. My dad used to drive a Hummer. Those things get like 8 miles a gallon, and they're huge. You can, of course, dress this up, make it a little prettier. So here's that same graph with a filled in dot instead of the open dot. I'm making it sky blue, and we're putting some labels on it as well. Cool, that's not so bad. Maybe you could show that to somebody else, but it's not fancy, right? So what else can we do in base R? I'll just show you a little bit more before we kind of get to the star of the show. So you can make a histogram. Here's the distribution of fuel economy. If you're not familiar with a histogram is a graph of a single numeric variable that shows the distribution of that variable. So you could see that the distribution of fuel economies here is centered around 20-ish and has these tails. It's not a big data set, so it's hard to say a lot more. So yeah, this is nice. Wasn't so many lines of code. If you want to get fancier than this, it actually does get pretty annoying in base R. So I kind of just want to move on to the next thing, which is ggplot. So there is a famous statistician and personal hero of mine named Hadley Wickham. You could read all about him. He's basically the face of the R programming language at this point. But back in the day, he thought there ought to be a grammar of graphics, a consistent way of a syntax for making a visualization. So he devised the ggplot library, which in my opinion is the greatest library in R for making static visualization, maybe in any language. At first glance, it does look a lot more complicated, but there's only a couple things to learn before the pieces start to become a lot simpler and you get to make some really, really cool graphs. I'm a huge fan of this library. There's a lot to learn about it. Hadley has actually written and published for free his own book on the library that he wrote. He's a really good author, so it's a really, really readable book. I linked it here. It's on his personal website. It's in like a blog format. Super cool. If you're not the kind of person who likes to read programming textbooks for fun, I get it. ChatGPT is actually really good at writing ggplot code. So, you could do that too, I guess. ggplot is actually contained in the tidyverse. So maybe you've heard of the tidyverse. It's a library with, I think, 9 libraries contained inside it. So I'm going to read in the tidyverse and bring in the diamonds dataset. So this is correct. If you are running this code on your own a little bit later, there are 9 separate libraries being read in. Of course, ggplot is one of them. There are some conflicts. You can ignore those. And this is the diamonds data set that we're going to be working with for the remainder of this talk. Each row is a diamond. A diamond's caret is its weight. The diamond's cut is its quality. So an ideal cut diamond, I had to look this up. So imagine the pointed shape of a diamond. A ideal cut diamond has a 90-degree angle so that the light goes directly down and bounces perfectly back out the other side. If you all knew that about diamonds, I don't. I'm a millennial, so I'm never going to buy a diamond. But the joke. That's an ideal cut diamond. We also have price in US dollars and a couple of things. Okay, so how do we make a ggplot? To make a ggplot, you just say ggplot of the data set, and you get a gray rectangle. This is nothing. It's a blank slate until you add things onto it. So how do we add things onto it? Every graph you want to layer onto the ggplot is a geom. So geom point is for a scatter plot. The aesthetic, that's that AES function in there, is where you tell it what columns of the data set are going to make up parts of the graph. So I'm adding a scatter plot on top of it, and the aesthetics are caret and price for X and Y. So the X-axis is going to be the caret or weight of the diamond, and the Y-axis is going to be the price. Cool, makes sense. Bigger diamonds generally cost more. There's more variables at play, but an upward slanting graph certainly makes sense here. We could do more here. So the aesthetic can actually go in the ggplot call. And if you do that, the aesthetics will actually carry down through later layers. So here I'm doing that same graph with the same scatter plot. I'm going to color the points green to prove to you I can do that. And I'm going to add on a smoother. What is that? Here we go. So this is sort of like a overall trend line. And there are, of course, a million different settings here. So on Geom Smooth, I could, instead of having a curved smoother, I can make a linear model smoother. So this can actually show the line of best fit right on top of it. And I can even turn the confidence band off. SE stands for standard error. So this is a little confidence band. If I want, I'm going to turn that off. The graph kind of looks like it's going out of control here because it has to follow all of the X's, and there are some outlying diamond sizes, but we can fix that all later too. All right, so what more can we do? We can make ggplots actually look really good and really publication ready. So let's make basically the same graph. We're going to take the smoother off. I'm going to leave the aesthetic as part of the definition. I'm going to add on theme BW. That's theme black white. There are a couple built-in themes. So if you see up here, the default graph is gray with white margins. I'm going to turn that into just the traditional black and white. I'm going to add on a new aesthetic. So I'm going to take the cut column of the data set that was like the ideal or premium cut of the diamond and add that as a third dimension. So the color of each individual point is going to correspond to the diamond's cut. And then I'm also going to change the size of the point and the alpha of the point. The alpha is a measure of transparency where 0 is invisible, 1 is perfectly opaque, so half is half transparent. The reason that size and alpha don't go inside the aesthetic is because they don't depend on the data. Only variables that depend on the data go inside the aesthetic. Then I'm going to change the color palette of the cut to be set one. It's like a predefined color palette that I think looks kind of nice. And I'm going to change the name of the legend. I'm also going to add an X label, a Y label, and then I'm going to trim off the outliers. So XLim sets the limit to be between 0 and 3. You can see that there are a lot of outliers out here that I don't really want to pay a lot of attention to. Okay, that looks nice, I think. I mean, maybe you don't like this color palette. That's certainly a lot of oranges and purples together, but this is a solid looking graph. We have changed all of the settings so that it doesn't look too like programming-y. You know what I mean? This is something that if you needed to, you could probably publish in a journal, at least in terms of the quality, not the content. Sorry, I see there's chats coming in. I don't want to ignore anybody. So I want to go back up and look at something. At first glance, if you've never used ggplot before, this also looks really complicated. This is a lot of lines of code to get a graph. But as I mentioned earlier, there's only so many pieces here, right? There's the ggplot, the aesthetic, and the geoms. Everything else you kind of just get used to, like adding on an X limit, adding on a label. That just kind of becomes, one more thing to add on. Every new thing you add to the graph is another kind of addition that you're adding on to it. Scale color brewer, I don't think I've ever written this successfully the first time. It used to be a lot of Googling. Now it's just politely asking ChatGPT to change the color of my color palette. So yeah, I agree that this can kind of get a little bit annoying. All right, what else can we make in a ggplot? There are a lot of different kinds of graphs. So histogram, of course, you can do that. Here's a histogram with a, sorry, geom histogram. I'm running out of vertical space here. I hope it's okay that I can zoom out one more and that's still readable. Let's make a complicated histogram. So we can, of course, add many different pieces of viz onto the same image. So here is a histogram with a density plot overlaid. Then I'm going to take the x-axis and make it on a dollar scale because it's the price. And then I'm actually going to shut the y-axis off because when you make a density plot, the y-axis doesn't make a whole lot of sense. So it's pretty, right? I made a sky blue histogram. The edge color, so the fill is sky blue. The color is white. The color actually refers to the border of the bars. I make the border white sometimes because it looks kind of nice to see that the bars are a little bit separated. And then I made a density plot over it. If you're not familiar with a density plot, it's basically a histogram but smoothed out into a line. And what did I make that? I made that navy with a transparent purple fill. So you can see the kind of slope out to the side here. There are cheat sheets available as well if you Google for ggplot cheat sheet. Yes, there are no shortages of that. I think almost all of the libraries in the Tidyverse have really cool cheat sheets associated with it. All right, more bar chart. So a bar chart is a way to visualize one categorical variable, and in this case with counts. So there are a little bit more than 20,000 ideal cut diamonds in this data set. This data set is not so big. It is 55,000 rows, but this is where I kind of want to bring your attention to what I said earlier. If instead of 55,000 rows in this data set, there were a billion rows in this data set, we would not be able to just ggplot it, right? You can't just ggplot a billion rows. It just doesn't work. What you can do is you can aggregate your billion rows and then plot the aggregation. So if you think about it, the only thing you need to actually create this graph are 5 rows of data, one for each diamond cut, and then the count associated with it. So instead of visualizing all 1 billion rows, I can group by and then plot the resulting grouped by data frame, which is only 5 rows in this case. So you can't do this if your data set was a billion rows. But what you can do is this. You can group by and count up the diamonds. So this cut frequency table, I actually printed out So if you are unfamiliar with tidyverse code, I'm just making a pivot table here, basically. So this is the resulting 5-row data set. And then you can make a bar chart out of this. When you make a bar chart where the y-axis is actually a defined variable, instead of geom bar, you use geom call. I don't know why it had to be a different thing, but it just has to be a different geom. But instead of visualizing a billion rows, I've visualized 5 rows, and that is how you can use large distributed data to make visualizations easy. Scatter plot, you want to make a scatter plot with a billion points? Don't. I mean, you can't really, but also the human mind can't really look at a billion points, right? So when people want to make a scatter plot out of large distributed data, they typically downsample it or aggregate it again in some way. All right. There's some other cool ones out here. You can make a faceted graph in ggplot. I don't make these too much, but they come in real handy when I do. So what you can do is instead of like coloring points on the graph a different color, you can spread them across different graphs. So here's a facet wrap of the cut. So this is the same graph we've been making, but with each cut spread across a different actual image. So now instead of one image with 5 colors, it's 5 images with 1 color. If you want to have completely unrelated graphs on the same image, there are actually a couple libraries out there. Back in the day, I used to use one called Viewport. It seems like Viewport has fallen out of favor, but there's a new one that I found that I really, really like called Patchwork. And actually, let me run this now because I need to install this library on every new node. So that should be done in a minute. What Patchwork does is you can use a syntax of slashes and pipes to kind of make a graph on one image. So here I have made 3 separate graphs, and ggplots are objects, so you can save them as variables. And here is the, what was it called? Patchwork. Here's the patchwork code. So I'm going to take P1 over P2, right, divided by over, right, and then a vertical bar, and then P3. So I'm going to literally make a graph that is what I just described. It is P1 over P2 and then P3 on the right side of the screen here. I just think that this is so succinct. I just think this is so like short and elegant. I also made a point here of introducing 3 additional graphs that we hadn't seen before. So this top left one is a freak poly, which I think is just a density plot, but made a little bit more jagged. On the bottom left here is a violin plot. Maybe you can see why it's called a violin plot. This is a cross between a density plot and a box plot. They certainly look cool. I have never successfully used one to need one, I guess. And then on the right here, it's not a new graph, it's a histogram, but it's horizontal. So the aesthetic is up to you. Normally we say X is the variable, but on this histogram I said Y is the variable, and that had the effect of putting the graph on its side, basically. Cool. So I hope this has really inspired you to use ggplot. I love ggplot. It's just like the sky's the limit with this library. It's really hard to think of anything you can't do in ggplot. I do want to talk about a third option called Plotly.
Hey, Tim, I did just
Yes.
want to give you a quick time check. We have about 1 or 2 more minutes until we need
Yes.
to administer our survey.
I need exactly 1 more minute.
Okay.
Yeah, I was keeping an eye. Thank you. So Plotly is a interactive library. So you can make actual graphs with mouse overs and things like that. It's interactive by default. It's rendered in HTML, so you can actually export them and embed them in web applications. And the library is cross-platform, so it's available in R, Python, and I think like JavaScript maybe too, some other libraries. Unfortunately, Plotly is not compatible with R in Databricks. It's compatible with R on your own personal computer, and if you want to try that out, I have some sample code here with the mtcars data. Of course, make sure not to use any protected data sets locally, but you can do it locally. But you can do it using Python in Databricks. So I know it's not R, and this is an R lunch and learn, so I want to sneak in some Python code here. So this is code lovingly written by ChatGPT. And here is some Plotly code. You can mouse over it. You have complete control over what the mouse over legend says. So really cool library. I know it's really popular in Python. R is getting there, but unfortunately we don't have it quite yet. Okay, and time. I'm done.
Thanks, Tim. Okay, so at this point, we are going to administer a survey. You can feel free to drop after you do it. We do want to just say a quick thank you so much for joining us today. And we hope we see you at some other of our sessions and offerings. The survey's purpose is to help us improve and continue making sure that, sorry, I'm simultaneously trying to also pull this up on my screen. Okay, so that's launched now. And just so we can continue making sure what we're offering is what is needed. And there is a place where you can ask those questions if needed also. So have a great day and thank you so much.
Thank you all for joining. Bye.